group's global MEP is gonna be a different portfolio based on your inputs of the 9 securities that go into it. So you need to know where this global MEP's return is, where its risk is, and then you can go from there. And to find the global MEP, last time, if you remember, the way to go about it is to minimize portfolio. So I'm going through this one last time with everybody, yeah? So pay attention here. For global MEP, minimize portfolio risk. So the cell that represents the variance on the portfolio, minimizing it by changing what? By changing the 5 weights, in your case 9 weights, the 9 risky asset weights. And the only constraint is what? The sum of the weight equal to 1. And making sure you uncheck this non-negative box. So this is all for global MEP because we don't know what its return is, so we cannot specify a return level. We just leave it wide open. As long as you minimize risk, that's all we care for global MEP. Yeah? Solve for it, you get a solution, you copy paste the value only down to table 1. And then based on this, all the other portfolios on the frontier can be constructed by keep adding one at a time portfolio return target. One at a time, and you pick the return level based on where your global MEP's return is. So you pick 10 above it, you pick 3 below it, you pick the return level. So one at a time, minimizing portfolio variance, changing weights, weights add up to 1, portfolio return, one at a time, equal to a level you desire. Yeah? For the short sale allowed, or what I call unrestricted case, box unchecked. Each time you find a solution that gives you that target level return on your portfolio you want, copy paste the weights, copy paste the portfolio standard deviation, and keep going. Yeah? That's table 1. Table 2, the only difference from table 1 is for the target level of returns you pick. You don't have to repeat global MEP, but for all the other level of target return you pick, above G, below G, for table 2, all you need to do is to click that non-negative box because you're restricting no short sale, which means none of those weights can be negative. Yeah? So that box there basically take care of the no short sale constraint. Everything else stays the same. One at a time for each target portfolio return level, and solve for it, copy paste everything down to table 2. So of course, for the target return that's higher than your best stock or lower than your worst stock, then there is no way solver can find a solution with no short sale imposed. So just say no solution. Okay. Once you get these 2 tables pretty much populated, the next thing we need to do is to find the optimal risky portfolio. So you get all these portfolios on the frontier ready. Then the next thing to do is find the optimal risky portfolio when there are only these 9 risky individual assets. Yeah? To find that, what we said last time, what do you need to do? Maximize your utility function. So you gotta go to Excel data solver, and this time you're gonna let solver know your goal now becomes maximizing your utility function that you already put the formula in by changing, again, the weights on the 9 assets. The only constraint is add up to 1 of all the weights. Make sure this box is unchecked because you don't know if you will have to short sale or not when you maximize your utility. Yeah? And solve for that. Keep solver, copy, paste down, mark it. This is my optimal risky portfolio when there are only risky assets. Repeat the same thing for your friend who is more risk averse, and you should see your friend will have a portfolio that has lower return, lower risk than you because they're more risk averse. Okay? So far, it's just all risky assets. And then we say, let's add the risk-free asset. Okay, so that's the second half of the Marcus portfolio theory. Add the risk-free asset. With risk-free asset added, with risk-free asset, before risk-free asset, it was like this. With risk-free asset added, my drawing is terrible. Everybody's optimal risky portfolio will have to switch to the tangent portfolio that has the highest Sharpe ratio. So no matter originally I'm here, my friend is there, or my friend is there, I'm here, no matter originally without risk-free asset where we are maximizing our utility, now with the risk-free asset added, your tangent portfolio becomes his, becomes hers, becomes everybody's, as that one has the highest Sharpe ratio. So to get to that one in Excel solver, now your goal becomes to maximize the cell that represents Sharpe ratio. Okay, so you already have the formula input there. You're gonna maximize Sharpe ratio by changing the same 9 weights with the restrict of weights add up to 1. Uncheck the box. Why? You don't know where that tangent portfolio will ask you to short sale or not. You don't know, so you cannot restrict it. You cannot restrict the tangent portfolio to have a certain level of return either, because you don't know where the tangent point is and what kind of return it's gonna give you. So all you need to do is maximize Sharpe ratio by changing weights add up to 1. Okay? Solver find solution, keep writing it down. This is gonna be your tangent portfolio or optimal risky portfolio when risk-free asset is included. This is not only your tangent portfolio, it's also your friend's tangent portfolio, your friend's optimal risky portfolio. Everybody's optimal risky portfolio is gonna be the same tangent portfolio that has the highest Sharpe ratio. Okay? So far, you guys still with me? And then, now that we figure out what our optimal risky portfolio is, so the next step is to figure out where our complete portfolio is gonna be by maximizing my utility again, choosing the weights between the risk-free asset and the tangent optimal risky portfolio piece stuff. Yeah? Your complete portfolio, your friend's complete portfolio can can be different points on this tangent capital allocation line because you and your friend have different degree of risk aversion. Yeah, but both of you hold the same F&P, so your portfolio, you may have P star this much, F this much. Your friend is more risk averse than you. Guess what? Their proportion of risk-free asset is gonna be higher than your proportion of the risk-free asset. You see that? And I think on my graph, I got the green and the red opposite. Your friend is more risk averse than you, your friend will be somewhere here. Okay, that's your friend with more money on the risk-free asset. So far, you guys with me? In Excel solver, how are we gonna find this C for me and my friend? What we need to do is to set up a new utility function. This time, the utility, your satisfaction, is obtained from the complete portfolio's return risk. So, knowing what is in the complete portfolio, the same tangent portfolio P, the same risk-free asset F, knowing that you and your friend both has these two assets, okay? You and your friend both have the same two assets. The only difference between you and your friend is degree of risk aversion. So all you need to do now is set up this little workstation here by first initializing the weights on the two assets, risk-free asset and risky tangent portfolio P. Set up the cell that represents the sum of the weights again with formula instead of the number 1. Set up your complete portfolio's return weighted average on the two components. Set up your complete portfolio's risk. Only depends on the risky part of the complete portfolio, which is the tangent portfolio P, and how much money you spend on it. Set up the return risk on your complete portfolio so that you can set up your utility function now with the complete portfolio. That is complete portfolio's return minus 0.5 times your degree of risk aversion, A, times your complete portfolio's variance. Yeah? So it's the same utility function format, but this time it's gonna be the complete portfolio that make you happy or sad. Once you set it up in Solver, all you need to do is to tell Solver to maximize your complete portfolio's utility. Yeah? So maximize the utility that represents holding the complete portfolio. This time, the variable you can change is only these two weights. How much do I spend on F? How many do I spend on P, the tangent? But I can't just change these two freely. The constraint is the sum of these two weights has to be equal to 1. Yeah? And since I don't know if I will short sell the risk-free or not, so I cannot click on that box, it has to be unchecked again. Maximizing the new utility with holding the complete portfolio by changing the two weights, one on F, one on P, but the two weights need to add up to 1. And that's it. Solve for it. So you can see my 0 weights now gets updated to to some different weights. Do this for you, do this for your friend, exactly same setup. The only difference is your friend has a different degree of risk aversion, yeah? And the result you're gonna get from running solver on you, maximizing your utility, and running solver on your friend, maximizing his utility, as we said, is your friend will have a higher weight on the risk-free asset because your friend is more risk averse, okay? So when you get your numbers, if your friend does not have higher risk-free assets weight, something is wrong. Go back, check your calculation formulas. So far, you guys still with me? Now that you get how much allocation you need to conduct between risk-free and the tangent portfolio P, the next step is pretty straightforward. If you are spending 56.6% on P, and P itself has what? Has 13% on A, 16% on B, 31% on C. So if that's what P looks like, and you're spending 56% on P, then on A, B, C, D, E, F, G, the underlying 9 security assets, each of their weight is just how much you spend on P multiplies by how much weight each stock is in P, yeah? So go back to your table 1, find that row that represents the weights in P, and multiply each one of them, okay? If you want to double check, in the end, sum up all the weights from risk-free asset all the way to the underlying 9th individual security, and that sum of weight should be exactly 100%, okay? If you sum up just the 9 security, then the sum of weights should be exactly equal to what you have there for P's weight, okay? Now those are your double check points. So far you guys still with me? So that's your complete portfolio, what it looks like, including F and including all the underlying assets. So now, for your question 11. So what did I say? I said, let's say using the end of last year's price. Okay, so at that time you haven't learned this class yet. And you understand you gotta diversify, okay? You pick 9 different securities, some ETFs, some individual stocks. And your idea of diversification at the time was, I'm just gonna spend equal amount of money on each one of them. I kind of spread out my money among all 9 of them. So you spread out $500 in all the individual securities, not the risk-free asset, just the 9 individual, okay? So at that time, each one of them is worth that much, the end of 24, so that's your last row on the close price, end of 24 price, yeah? You have that data. So you could figure out how many shares you can buy with $500 on each. $500 divided by price. So far, are you guys with me? Right? That's how many shares you were buying at the end of 24 in order to diversify. But now, 2 months into it, so you will need to find what's the latest price is on the 9 assets, okay? So it can be as of February 27th today, or as of February 26th. So find some date that's more recent, get its price now. So what you're gonna do is, back in December 31st, spreading 500 even on each of the 9 stocks, you end up with 8.31 shares on A, 15.5 shares on B, and by the way, fractional shares these days are fine. Lots of brokerage firms allow you to do fractional shares. So fractional shares, no problem, okay? So you already hold that many shares of A, B, C, D, E, F, G, but their price has changed from December 31st to now, right? So now you want to know how much your portfolio is worth. How much is it worth? Each number of shares multiplied by each price, current price, okay? And the sum product function is a good function, again, weighted average to figure out. Actually, might be something wrong here. Could somebody tell me where I did wrong? Sum product, hold on. I didn't do it wrong. I'm still using sum product, sorry. Didn't do wrong. Sum product function still works. Why? Because I'm using number of shares times the price of each stock at the current time, yeah? So it's not weighted average, it's just price times N. P1N1 plus P2N2 plus P3N3. Okay, so far you guys still with me? I had a moment of doubting myself, but I'm correct here. Sum product can still be used. Question. You're still with me? So basically I'm trying to figure out how much my portfolio is worth now, okay? By using current price, but figuring out how many shares I own in each stock with the $500 at the end of last year. So I know how much my portfolio is worth now, and I know what the optimal weight is now, based on what I learned from the portfolio theory, right? Based on what I did just recently. That is, what are the weights? Okay, I can't spend all of my money on risky assets. I got to spend 43% on risk-free, and for the others, I already figured out what's their weight. So I copy paste those weights down here for A, B, C, D, E, and the risk-free asset. Now I can know how much dollar amount that I need to spend with my current portfolio value onto each stock using the optimal weight I calculated for my C, right? For my complete portfolio, that's worth $2,500, 92 cents. I mean 25, 92, 28 cents. For my complete portfolio, now I know with this weight structure, instead of just spending them equally on all the 5 risky or 9 risky, now I know how much dollar amount I need to spend on each one of them. And I will know how many shares at today's or the most recent price, how many shares that translate to, yeah? Dollar amount divided by the current price. So now I will know what kind of trade I need to conduct. So back December 24, to spend 500 even on all the risky asset, I bought this many shares of each. Now I know how many shares I need to buy or sell, okay? And don't forget, originally you were only on the risky, but now you know with the risk-free asset, you can allocate your money better. So whatever risk-free asset, that is just gonna be your money that's parked or invested on T-bill, okay? So that's your question 11. That's the kind of setup. And of course, your number will be different than mine. Now, so far any questions before I move to the picture, the graph? So far you guys still with me? Yeah? 2 people nodding. What about the rest of you? You're still with me? Good. So now let's look at the graph. Okay, the graph itself tells a lot of story here. I'm gonna minimize know what is your input, right? So to draw this graph, go to insert charts. Of all the charts here, pick the scatter. Okay, so the little dots there. Pick the scatter, and out of all the different scatter charts, pick that second one that connect the dots of the scatters. Yeah? So far, are you still with me? Insert, scatter, second. Okay? After you do this, right click, select data. So you need to let Excel know what input. You're gonna let Excel draw a bunch of stuff. Select data. Okay? Leave that top box open. Just keep adding series. Okay, you have a bunch of series that you need to add to this Excel scatter graph. The first series you're gonna add is the minimum frontier, and you can give it a name, with short. Okay, basically short allowed. So basically, the first series is what I call the unrestricted frontier from table 1. So that's the name you give it. You're gonna let Excel know what is on the X, what is on the Y. And what's on the X, what's on the Y, is gonna be the same thing that we've drawn with our hand. Standard deviation, risk on the X, ER, return on the Y. Okay? So go back to Excel, table 1. So this is why you record all the numbers, results from each run of solver. What's your X? Your X is gonna be the column that represents portfolio standard deviation. Yeah? What's your Y? So get rid of that 1 there in Excel. What your Y is gonna be your portfolio return. That's your Y, okay? And click OK. Look at it. All right, so this is my new graph that I just draw. So you can look at it, stretch it out. My unrestricted frontier, by connecting all the dots, mostly look all right, but there is this one little stretch way down. The reason why this one is way down there, you may see something like that too, is because I chose a portfolio target return that's below my lowest stock, right? I chose that, and I asked you guys to choose it too, but that target return below my worst stock is way below the rest of them. So because I didn't choose any more points in between that lowest target return and my next lowest target return. So all Excel can do is connect those 2 points with a straight line, okay? So it doesn't look very pretty there. You may see the same thing with your lowest target return or with your highest target return, because most of your other portfolio returns are somewhere near the global MEP, but to satisfy my requirement of going beyond, right, you may stretch it out. So if you see something like this, do not worry about it. What I can do and what I accept is get back to your series, edit on it, and get rid of that first, in my case, the first row of the lowest return, okay? So that point to me is somewhat an outlier there, so I'm just gonna get rid of it, and now it looks a little better, okay? Without the stretching all the way down. So you can definitely work like that to pick your X and Y. Okay? So far, any questions? Now, I ask you to draw everything on one graph. So it needs to be one graph. That way you can see the relationship. You draw it for the first series. You can draw it for all the other series. No short cell allowed. That's table 2. The tangent line. And you can add each individual security, A, B, C, D, E, F, G. You can add everything to it. You can add your portfolio without F, your complete C, your friend C, and all that stuff. Each series is gonna be one curve or one point or one line. So with no short cell, as you can tell, with no short cell, as you can tell, all I need to do is what? Go to my table 2, when short cell is not allowed, and still pick the X and the Y, but this time X and Y are gonna be restricted to only the ones that Excel find solutions, yeah? For Excel that cannot find a solution, there won't be any point. So that's why you see my X and Y are has less points. Okay. So far, you guys still with me? But X is still portfolio standard deviation, Y is still portfolio return. That hasn't changed. It is the same level of portfolio returns that you picked for the table 1, okay? Same level portfolio return, with the exception of global MEP, because that number there is not an exact number. Oops. So far, you guys still with me? So, before we add more lines and points to it, let's look at it. So, let me drag my graph down a little bit, maybe you can see better. Get a little smaller. So, yeah, it's kind of hard to see. My unrestricted frontier is the blue, and then my restricted frontier when short is not allowed is the maroon, okay? So, yours might be different, okay? It all depends. So last time I remember, Carson, you said, even starting from your global MEP, you have to short sell, right? So, I don't know about the points that you picked for the other returns. Did you have to short sell for every single one of them, the returns? Or just some of them you have to short sell, some of them you don't have to short sell?
I'm not for sure because I messed up the global MVP.
Oh, okay.
So
That's
it
all right.
could have not been shorted.
Yeah.
I honestly
Okay,
don't
you
know.
could have. Okay. Here is the thing. If in your table 1, some of it you have to short sell, and then in your table 2, when you restrict short sell, the weights on the short sell stop become 0, like mine. Then what's gonna happen is what? For the table 1, table 2, for the numbers that are exactly the same, the 2 frontier will overlap, because they're the same, it's the same points, right? Like mine there. However, later on, when you restrict short sale, say, hey, you can't do it, then it starts to depart. The one that restricts short sale will have to be inside the unrestricted one. Inside means what? Inside means to the right. To the right means what? To the right means it's higher risk. You can still get to that level of return, but when short sale is forbidden, you have to incur higher risk for that same level of return. And the higher risk on the graph is it banded down towards the right. So just like what my maroon graph there shows, it bended towards the right. At first they overlap because my table 1, table 2 have some numbers for certain level returns that are exactly the same. Yeah? Same returns, same risk, same weights. But then it starts to deviate. You may see the same thing. Or you may actually see something, you may actually see your unrestricted unrestricted frontier like that and your restricted frontier like that, it could be something like that. Because that means for your unrestricted frontier, when short is allowed, you have to short sell every single time in order to reach minimum variance, minimum risk. But then later on, if short sale is not allowed, then yeah, you can still get to that return, but each time you have to incur higher risk. Yeah? So far you guys with me? So if you see something like that with your frontier, don't panic, it's totally okay. Yeah? The restricted frontier will always be either overlapping or inside of the unrestricted frontier. That part does not change. All right. So far, you guys still with me? What about the tangent line? How am I gonna let Excel draw the tangent line for me? Tangent line has, each line has points on them. Once you connect the points, Excel can draw the line. So here is F, and you already figure out what the tangent portfolio P is. If you only give Excel these 2 points and ask Excel to draw it, Excel can draw it, but then it will just be from F to P, that's it. 2 lines, 2 points, 1 line. So what I like to do is I want to give Excel a third point that's outside of P so that Excel can connect those 3 points when it draws that scatter graph. But first thing first, I gotta let Excel know what this third point is. What's its return? What is its return? What is its risk? Yeah? So what I did here, right underneath table 1, after you figure out the tangent portfolio with the highest Sharpe ratio for you and your buddy, I added the risk-free asset here. 0 risk, risk-free rate, copy paste from, the table up there. And I also add that third point that's outside of P. That third point that's outside of P is, in my case here, is a 150 -50 allocation, which means what? If I want to go outside of P, I have to short sell risk-free asset. If I don't short sell risk-free asset, I'm just gonna be somewhere in between F and P, invest money on F and P, yeah? So if I want to go outside, find that third point that I can draw a prettier line, I have to short sell F. So I say, okay, my weight on F is negative 50, but my weight on P is positive 150. So the 2 weights still add up to 100%, but now I'm going beyond P, yeah? So far, you guys still with me? I have $100, I'm gonna short $50 worth on the risk-free asset, and I'm gonna what? Invest 150 on the tangent portfolio P. So that's how this kind of weight come to be, yeah? So, you don't have to do 150 -50. If your graph is already stretched pretty big, you can just do 120 -20 or 110 -10, some point outside of P. That's all I'm asking, yeah? So, but I need to let Excel know what that portfolio X return is, risk is. So, portfolio return, always weighted average return, but this time, the weight is gonna be 1.5 and negative 0.5, yeah? So when I plus negative weight, it's like minus 0.5. And then the 2 returns, I conveniently put them right there by me. Portfolio risk on that portfolio X, just like your complete portfolio C, risk only depends on how risky the tangent portfolio is, sigma P, and how much money you spend on P. So you spend 150% on it, so 1.5 times that sigma. And that's it. There is no risk-free risk. Why? Because risk-free has zero risk. There is no covariance correlation term. Why? Because risk-free has zero correlation with P. Yeah? Now that I have the three of them all listed together, so this is why I list them together. So in Excel, when I draw the tangent line in the graph, in the same graph, if you look at my tangent line, I'm just gonna select X that are in table 1 for this three, oops. So the X is just gonna be this 3, the Y is just gonna be the return of this 3. So I put them together, okay, just so that I can highlight them better, easier. Otherwise, if you have them one cell here, one cell there, one cell, it's hard to put them all together when you tell Excel what is your X. Does that make sense? So I just put them together, and so that I can drag it in. All right. So that's my tangent line. So as you can see, my risk-free is right down here. My tangent point is that orange triangle right there. So it's kind of hard to see. That's my tangent P. That's my F. And then my third point, that's my X. So I gave Excel these three portfolios: return, risk, Y and X. All Excel does is connect the three, draw the straight line. Yeah? Again, if you don't give it this X, Excel is gonna stop right there at P. Only 2 points connected, okay? So the next what I did is I'm gonna add all these individual portfolios and stock into it. And all you need to do there, that's my stock C, that's my stock E. All you need to do that is add them one at a time. So continue to add a series, okay? But this time the series is each individual portfolio, individual stock. When you add them, you will see, again, Excel asks you what is their X, what's their Y. The thing with individual stock, individual portfolio is what? It's a point. So their X is just gonna be what that stock's standard deviation is, yeah? So what that stock standard deviation is, what that stock's return is, okay? So you do it one at a time, okay? 1 point at a time. For A, for B, for C, D, E, F, G. And you do this for the portfolios that you calculated in table 1. Your P without F, your C, your friend C, your tangent P, all of this. Because why? You already recorded each portfolio's return and risk down. So all you need to do when you draw them in the graph, add them in the graph, is to let Excel know what is its return, what is its risk, and Excel will pinpoint them on that graph. Okay? After you draw the graph, look at it, ask yourself, does it make sense? Okay? So let's look at mine. We already mentioned the frontier with short cell constraint and the frontier with no constraints. You already see the constraint one, the restricted one, is inside, or at least partially inside. Look at the individual assets. In my case, there are 5 of them, all these little dots. This is 5 individual assets that I construct the frontier from, right? Look how far to the right they are. You see it? Look how far to the right they are compared to your frontiers. What does that tell you? Quick! What does that tell you? Carson? Outliers. Well, my five of the, yeah, maybe my D is probably the worst one. That's one I kept short selling, and I can see why, because it has the lowest return there. But all these others, you know, my A, B, C, D, C, E, they're okay. But look how far right to the frontier they are, which means what? How far left the frontier is compared to individual stock. What does that say? It's the power of diversification, guys. If you just spend your money on any single one of them, you're gonna end up way to the right on this graph. Way to the right means too much risk, yeah? However, if you mingle them together, yeah, diversify among even just 5 stocks, or among yours just 9 stocks, you will see your frontier is a whole lot more left than any individual. Left means lower risk, but for the same level of target expected return you want to achieve. I'm not sacrificing any return at all, but yet I am reducing risk through diversification. So once you draw everything onto one graph, you should see clearly the power of diversification, okay? And keep going. After you draw the tangent line, after you draw, you draw your friend's C here, your C here, so it should make perfect sense. Your friend's complete portfolio is what? Is closer to the risk-free. Why? Because your friend's is more risk-averse. So far, you guys still with me? Without the risk-free asset, your friend's optimal is right here. I know it's kind of hard to see. And yours is to the right. So it's on the blue, on my case, on the blue frontier. Mine is higher than his. Why? Because he is more risk-averse than me. Okay, so all those points should make sense once you start to let Excel pinpoint where they are on your graph. And with the tangent portfolio, so originally I'm here, your friend is here, I'm here, but with the risk-free asset added, we both switch to the tangent P right there, but that P is too risky for me, right? So, that's okay. I can adjust allocation between F and P so that my and my friend's utility can be maximized. If I don't switch to P, guess what? My friend will be stuck on this line. And I will be stuck on this line. I know it's kind of hard to see, sorry guys. So which means either my friend or me, both of us will be stuck on a lower capital allocation line than the green line. Lower capital allocation line, no matter where we end up on that line, you know, we can still be here or here, but we're not gonna get a high enough return for the same level of risk, yeah? So that's what this graph shows you. With that being said, the first 11 questions on this project 2 should be done. Questions?